In this video, I'm going to go through two application problems for solving a system of equations by elimination specifically. And these are just a little harder because you have to create the equation yourself first. So I want to talk about how you would do that. It says here that you are selling tickets for Friday's basketball game. The student tickets will cost $1.50 and non-student tickets will cost $3.25. You sold a total of 358 tickets and made a total of $752.25. Let X represent the number of student tickets. So I'm just going to kind of write that down. X is going to be my students. And Y will be non-student. And, okay, so Y represents number of non-student tickets sold. Write and solve a system of equations to find out how many student tickets were sold. Okay, so I just have to find out one of them. So let's talk about your functions here. There are three linear functions. Y equals mx plus b, y minus y1 equals m, and then in parentheses x minus x1. And then there's one more form of a function, and that would be ax plus by equals c. Now, in order to fill in your mx plus b, you need to know two things. And you need to know your m and your b. To use point slope form, you need to know your point, 1 point on the graph, and your slope. And to know standard form, you just got to know a coefficient for x, a amount of x, and an amount of y, and equals some sort of total. And that actually fits best our scenario here, because none of the numbers that I had were slope, and none of the numbers that I had were specifically a point. And so I know I need to use standard form based on the type of form that I have. So the first form that I'm going to do of my equation is going to be a cost formula. So it will look like this. The amount of student tickets cost $1.50, so $1.50 per student ticket, plus your adult tickets cost $3.25, and you made a total of $752.25. And so that's our money plus money equals money equation. And then we were selling tickets. So the next function is actually pretty simple, and it might seem like, oh, really, that's it? And it will be. You sold student tickets plus you sold non-student tickets, and the total number of tickets that you sold was 358. And so the next one will be you sold tickets plus you sold tickets equals the total sold tickets that you had. So I'm going to say sold number of tickets. Okay, so now these are the two equations that I have. In order to do elimination, I need to create opposite coefficients. So I'm going to multiply my second function by negative 325 because they asked me to solve for student tickets. I don't want to eliminate the x's because I want to know what the student tickets are, so meaning I need to solve for x. So don't eliminate x in this problem because it asks, how many student tickets did you sell? And if student tickets are my x, that means eliminate your y. So that's why I'm going to multiply here by negative 325. All right, so let's actually multiply. So my new function will be this. Let's multiply negative 325 times x and negative 325 for my y. And now 358 times negative 3.25 is going to give me negative 1,163.5. Now, my original function I'm going to copy down for the cost, the $1.50 and the $3.25 for the non-student tickets, and then that was the total number of money that we made. So now I wanted to eliminate my y's because I needed to find my student tickets, and my student tickets I didn't want to eliminate because I needed to solve for them. So I need to keep that x in my problem. All right, so here we go. Let's use our calculator. Negative 3.25 plus $1.50 is going to give me negative 1.75 for my x. My y's are gone, which is what we wanted. And now negative $1,063.50 plus $752.25 will get me negative $411.25. Now let's just divide by our coefficient. Okay, so hit divide by negative 1.75, and I get total number of student tickets, 235 student tickets were sold. There we are. All right, I'm going to turn my page, and there is one more word problem here that we'll go through next. In this problem, it says that this name is Robert. It got kind of cut off here at the edge here, but Robert is 12 years older than Helen. And then it says the sum of their ages and years is 175. X will represent Robert's age, and Y will represent Helen. Oops, 1L, not 2. And then write and solve a system to find out how old Robert is. Well, if it says that Rob is younger than Helen, my Helen is going to be older, right? So let's see here. Let's see. Rob is 12 years older than Helen. I was thinking younger for some second. Okay, Rob is older than Helen. So if I take Rob's age and I subtract Helen's age, Rob is older than Helen, then when I subtract their ages, they're going to get 12, because Rob minus Helen gets us 12. I'm just going to write R and H here just so I don't get confused. And then the sum of their ages, so add them together, you get 175. So the difference of their ages is 12, and the sum of their ages is 175. Now I noticed that if I were to combine these equations right now as they are, my y's are going to cancel out here because my y's are already the same coefficient of 1 and they're opposite signs. So really I have two x's are equal to 175 plus 12, which is 187. Now if I divide both sides by 2, I will get Rob's age. I got let me fix this. 175 plus 12, and now divide by 2. Oh, I see what I did. Why did I write down 175? Shouldn't it say 178? No wonder. Okay. Just a distraction moment here. 178. Let me fix that, which means this is going to change. 178 plus 12 is 190, not 187. I kept getting a half number, and I thought, well, that's really weird that they would say a half. Okay, now divide by 2. Here we go. I fixed my problem. 95. How old is Robert? Robert is 95. You know, if you ever make a mistake, it's okay. Just see if you can fix it. See if you can find where you made your mistake, and then you can learn from it next time. Next time I know I just need to pay a little bit more attention and make sure that I write the right number in my equation. You know, if it happens to you, that's okay. Persevere.